Hello, I'm your narrator for this episode. This is Iran. You know it, a country with a missile program that began about 3 decades ago. Iranian ballistic missiles. April 2024, October 2024. 2 dates that changed military equations that had existed for decades. 200 ballistic missiles in a single night. For the first time in history, a direct launch from Iran towards occupied watermelon.
Not through proxies, not indirectly, directly. And of course, everyone was watching. Every capital, every analyst, every radar screen in the region. But before we understand what happened on those nights, we need to understand the tools, the missiles themselves, where they came from, how they evolved, and why the world cares about them so much. And the beginning of this story? It starts with a North Korean missile.
In the 1990s, Iran decided it wanted missiles, not birthday rockets, real ballistic missiles. The engineers sat down and asked, "What do we build?" Then they looked at the catalog and decided to start with what they already had. The idea was simple: a rocket that flies far, carries weight, and doesn't fall on the head of the person who launched it, the basic equation of rocket engineering. And Shahab 3 began to take shape on paper, a blank sheet, a long dream, and many problems that had not appeared yet. The problem is that building a missile from scratch takes decades. So, Iran looked toward North Korea. They shook hands. North Korea provided the Nodong-1 design. Iran said thank you and got to work. This isn't a secret. Everyone knows it. They took the original design, added to it, modified it, lengthened the fuel tanks, and changed a few details, like using a recipe you found on the internet. The result? Shahab 3. The name means meteor in Persian, a beautiful name for something you definitely don't want above your head. 1998, the first test. Everyone stands far away, very far away. That is always a good sign. The missile on the launch pad, more than 15 meters tall, heavier than 16 tons. It uses liquid fuel that takes hours to load. The engineers are watching. The commanders are watching. The cameras are watching. Every person there hopes for the same thing, that it doesn't explode on the ground.
And it launched. It rose. It pierced the clouds. And at that moment, everyone decided the project was a success. Officially, 1,300 kilometers. That was the initial range of Shahab 3. How far is that exactly? Enough to reach from Tehran to many places in the region. 760 kilometers. That is the weight of the warhead. Roughly the equivalent of 5 very overweight people. A warhead isn't just a chunk of explosion. It involves design, timing, and a separation mechanism from the missile body. Complex engineering inside complex engineering. Imagine it like this. The missile body carries this mass for more than 1,000 kilometers, then releases it to continue on its own. And this is where the fun physics begins. What happens when that mass re-enters the atmosphere at high speed? We'll get to that later. The first problem with Shahab 3, liquid fuel. And filling the missile with fuel takes long hours before launch. This means any enemy with satellites, and everyone has satellites, can see the launch preparations well in advance. This is exactly why Iranian engineers would later try to switch to solid fuel. But that is another story. For now, liquid fuel, a large missile, and yellow smoke. Old school technology that still works. 1998, Iran officially announced Shahab 3. In front of cameras, in front of the world, and with unmistakable confidence.
On TV screens around the world, Iran is testing a missile capable of reaching. Some countries worried, some worried more, and some immediately started building things to defend themselves from this very missile. Occupied watermelon was at the top of the very worried list, and for good reason. The range reaches it exactly. Meetings, maps, numbers, scenarios, the occupied watermelon military began asking one question: how do we stop this thing? The answer was, build a shield. The Arrow project began taking shape much more seriously after this announcement. Washington called, Tel Aviv responded, and a defense partnership began that would last for decades, all because of one missile on an engineer's paper. The shield idea was simple: make a smaller missile that flies toward the big missile and destroys it in mid-air. Simple in principle, catastrophic in execution. Arrow 1, then Arrow 2, then Arrow 3. Each generation flies higher, faster, and smarter than the last. That's what a threat does. It forces you to innovate. After years of development, the shield was there. But was it enough? No one knew the real answer until it was actually tested. And the real test, it hadn't come yet, but it was coming. Slowly, steadily, after decades of preparation on both sides. Shahab 3 was the starting point, but engineers never leave anything as it is. Never. 2004, Gad appeared, taller than Shahab, slightly heavier, but its range reached almost 2,000 kilometers. 2,000, almost double the first version. How? Amazingly simple. They lengthened the fuel tanks, used lighter aluminum alloys, and reduced the warhead weight from 1,000 kilos to 650. But range alone wasn't enough. The missile needed to hit a specific target, not just a general area. Gad came with a new warhead design, the baby bottle shape as analysts call it. This shape improves aerodynamics and increases accuracy. 2015, Iran revealed Imad. This time the difference wasn't just in range. Imad, meaning the pillar in Persian, came with something entirely new, a finned warhead capable of guidance during re-entry. For the first time, Iran announced a missile that can guide and correct itself until the moment of impact. A big claim. And the world listened. 50 meters of estimated accuracy, that's what Iran claimed. If true, and that if is big, all interception calculations needed revision. April 13th, 2024, a night that became history. For the first time ever, truly the first time, Iran launched ballistic missiles at occupied watermelon directly from its territory. Not through proxies, not indirectly, directly. This was a decades-long game-changer.
About 120 ballistic missiles, plus 170 drones and cruise missiles. A busy night in the Middle Eastern sky. The decision was made, and now physics takes over. Missiles don't know politics, they only know target, trajectory, and gravity. 120 ballistic missiles in the air at once, each one flying a calculated path, each carrying a warhead. The distance from Iran to occupied watermelon is about 1,600 kilometers. The ballistic missile covers it in roughly 12 minutes. 12 minutes only. In those 12 minutes, defense systems in occupied watermelon, Jordan, and US bases in the region moved. Everyone was awake. Shahab, Ghadr, and Imad on their first real mission. Not a test, not a military show, a real mission. Arrow 2, Arrow 3, David Sling, Patriot, every interception system working in coordination. This is what they trained for years. In the high atmosphere, at altitudes invisible to the naked eye, missiles collide with missiles. Occupied Watermelon announced an interception rate exceeding 99%. Other sources said 84. Whatever the real number, the result was less than planned. Let's put the numbers on the table. In the April 2024 operation, 170 drones, 30 cruise missiles, 120 ballistic missiles, total about 320 projectiles.
99%. If that number is accurate, and it's debated, it's a historic achievement for the defense systems. But even if we take the lower figure, 84%, that still means 16 missiles or more completed their path. But the big questions remained unanswered. Will the defense succeed again, and will the next missile be different? Two questions left hanging until October 2024. Shahab 3 finished its chapter, but before we move on, let's reveal what came immediately after. There remained a smaller missile, lighter, much faster, and a very big claim attached. A claim made with a single word that caused a stir in expert circles around the world. Just one word.